Hi CTM students, welcome to the Chapter 6 review, Part 2 of this. We had a Chapters 5 and 6 Part 1 review earlier, but now we're checking out Part 2, the last half of Chapter 6 here. Some algebra review mostly for what we have here. Some things you should have learned in either Algebra 1 or Algebra 2. If you are not a CTM student that happens to be watching this, this will be great stuff if you're looking at something to review algebraic concepts. But let's start out with number 41 here. And correction on that, 42. For my students at least, I'm just assigning the multiples of 3 in a lot of these portions, so I'm going to do every third one for many of them. Just check out the assignment sheet that you have been provided with to check out to see what numbers I actually assign. The ones that you have to do are the ones that I'm going to do up here. So number 42, it's saying J is directly proportional to the square of A if J equals 32 when A equals 4. Find J when A equals 7. So to set this one up with direct proportions, we're always saying this varies and then this constant term constantly as this thing does. So as the square of A, so we'd have A squared right there. So 41, I'm not doing that one here because I didn't assign that one. 43, same thing. 44, same thing. But you should be able to look at these and do these ones as well. So I'm just doing the ones that I've assigned. But check these ones out too. If you're like, I'm not sure if I could do that one, try them. They're in the back. They're all in the back of the book. Even the even answers are in the back of the book for this one. Odd and evens are all back there. So try these other ones too. Make sure you look at each problem. Say to yourself, I could do that problem. I know how to do that one. If you can't say that to yourself honestly, then you should try it. Ask me questions if you don't understand it. Let's see though. We got J as 32 originally, or in this case, if J is 32 when A is 4. So I could plug in 32 for J. I could plug in A as 4, and then I can solve that for K. I can get my constant of proportionality that way. So I have 32 equals, this would be 16K. I'd divide both sides. I'm thinking of my answer already. Divide both sides by 16, and I'd get K equals 2. Now that's not my final answer, but that allows me to get my final answer to find J when A is 7. So I'm going to take this now, do the same thing. I'm starting out with J equals KA squared. I'm going to plug in 2 for K. I know that's my constant of proportionality. Plug in 7 for A, solve for J. This would be 2 times 49, which would be 98. So J, when A is 7, and because K is 2, we solve for that, J would have to be 98. So 41, 43, 44, at least check those out. Make sure you could actually solve them, but we're skipping ahead now and doing every third problem, all the multiples of 3. Little clever trick. I've taught this before in class, but if you take these two numbers, add this one and this one together, 4 plus 2, that's 6. 6 is divisible by 3. That means this number is divisible by 3. So if you add the digits together, 4 and 5, that'd be 9. That's divisible by 3. 9 is divisible by 3, so therefore 45 is divisible by 3. So we're going to do these two here, but again, you should read these ones at least. Say, yeah, I could do that one. If not, you should try it. And then if you still can't get the right answer, check in the back, then talk to me, because any of these types of questions might show up. We're just doing selected ones. I don't want to overburden you with literally like 70 or 80 questions. So we're doing a selection of them. So buying fertilizer, part A, a 30 pound bag of fertilizer will cover an area of 2,500 feet squared. How many pounds of fertilizer are needed to cover an area of 12,500 feet squared? So to me, I'm seeing this as a proportion right now. I haven't done any of these problems yet. I'm just going through them for the first time, just like you are here. But so if I make some mistakes, I will make sure I go back and correct those mistakes. I'll be checking my answers in the back just like you should be. But I see 30 will cover 2,500. So I'm going to say that fraction should equal X pounds. I don't know how many pounds. So let's say let X equal number of pounds. Get in good habits here. Let's say what these things stand for. So of fertilizer to cover 12,500 feet squared. Okay, so x over 12,500. From there I would cross multiply. 2,500 x would equal this times 30. Let me get out my calculator for that. 30 times 12,500. 30 times 12,500. So I've got 375,000. I'm going to divide both sides by 2,500. That would cancel out there and there. So divide this by 2,500. I've got 150 for my answer. I also noticed that this here to this was 5 times bigger than this, so I could have done that as well. I could have done this times 5 would give me 150. That's another way to think about that one. So 150, this is 150 pounds. And so part A, that's good. And part B, how many bags of fertilizer are we going to need? Well, if one bag, a 30-pound bag, covers that. Remember, this was 5 times bigger. We saw that, but why is it 5 times bigger? Oh, that number just came from that. I had done that in my head. 150 divided by 30. You can cross off the zeros. 15 divided by 3 is the same thing. That would be 5 bags. And continuing with number 48 now, a falling object. The distance d an object drops in a free fall is directly proportional to the square of the time. If an object falls 16 feet in 1 second, how far will an object fall in 5 seconds? And so we've got d being equal, directly proportional. So we've got this constant k term, this constant of proportionality to the square of time. So times t squared, we'll call t. That's what we have here as time. So if an object falls 16 feet, this is going to be my distance originally, and this is going to be my time originally. So how far will it fall? So that's a new distance, and then in 5 seconds that would be a new time. So this is my first distance and time. These two will be my second distance and time. So I'll need to solve for k first. So I have d would be 16 equals k times 1 squared, and then 1 squared, that's just 1, so we really don't need to think about that. So we have k equals 16. That would mean that we would have, again, d equals k times t squared, but I know that k is 16 now. That's my constant of proportionality. And my time, 5 seconds, so 5 squared, and d would equal that. So d is going to equal 16 times 25, and 16 times 25, that's like, think of 4 quarters in a dollar, so we've got that times 4 more. We've got 16 quarters would be $4. So we have 400 for the distance. That is in terms of feet. You could use a calculator for that, though, if that wasn't making sense, the money observation I was making there. On to number 51 now. So 51, it is saying that we have 3 times x plus 9 less than or equal to 4x plus 11. So first distribute that x. We'll have 3x plus 27 less than or equal to 4x plus 11. Then we want to get the x's on one side and the regular numbers on the other side. I'm going to keep my x's positive by subtracting 3x from both sides, and then I'll subtract 11 from both sides. So this would be 16 is less than or equal to x. Another way to write that is that x, this is the larger one. The alligator is eating the bigger number. It's pointing at the smaller number. And so you could also write that as x is greater than or equal to 16. That's generally how we'll see it, with the variable out in front. But either one of these would be fine, acceptable. So it says to graph the solution set. So this is not our final answer. We're going to take that now and graph it. But I'll put a 0 here, I'll put a 16 out here, and then we would fill that circle in, and we'd say everything that's greater than or equal to that. So filled in circle means or equal to, and then greater than would imply that we shade it this way. So this is my x number 9. We're talking about things that are going in that direction. Alright, so these other ones, you can try those. Check those out in the back if you want, but make sure you know how to do each one of those types. Here, 54, graph the solution set for the set of integers. So we have 54, 5x plus 13 greater than or equal to negative 22, I would subtract 13 from both sides, trying to get x by itself. That would leave me with this, divide by 5, which would leave me with x is greater than or equal to negative 7. So not my final answer there. And I'm graphing this for integers here, it says. So integers, so I'm going to start here. I'm going to say I'm at negative 7 right here, and it's greater than or equal to. So I can fill that one in. But since it's integers, I can't just shade everything. I just have to go up one at a time. So negative 5, negative 4, negative 3, and so on. I can shade that one, or I can fill that spot in, but not stuff in between. It doesn't include non-integer numbers, just the integers themselves. So it's stuff that's greater than, so it's that, and then we were designating that this pattern continues by just putting a dot, dot, dot above the graph like that. Okay, so that's number 54. That's good to go there. Number 57 and number 60, graph the ordered pair in the Cartesian coordinate system. So let me get the grid on here for this one. And I'm going to plot these both on the same set of coordinates. That's going to be totally fine. So 3, 4, 1, 2, 3, 4, 5. Okay, that should be enough. And I've got 1, 4, that's a point right there. So this is my x, this is my y. This is always, the x comes first and then the y. The x comes first, then the y. So to do your x, go rise, or do the run part first. So this is 1, and then up 4. You've got a point here at 1, 4. So this is number 57 right here. And number 60, we're going to the right 5 and down 3. So right there is the point 5, negative 3. So that's for number 60 right there. So pretty easy, pretty straightforward there. I had assigned number 61 here. It's not a multiple of 3, but this was one where I inserted that into there. So 61. We are plotting the points, finding the coordinates of the fourth point to complete a rectangle. So we're going to make a rectangle, and then we need to find the area of the rectangle after that. So we are plotting these points first. We got negative 3, 3, 2, 3, 2, negative 1. Looks like we won't have to go too far in any direction. I'll just go 5 in each direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That should do it for me. Right there. Okay, if you have straight edges at home, I would say use those, but I've got the grids. If you have graph paper, so good to use graph paper with questions like this. It makes it so much easier, but if you don't, just do the best you can with what you got. So this is A, negative 3, 3. That's my x and y axes right there. This is going to be at 2, 3 right there. B, this is at 2, negative 1. So down here, so I think it's clear from that point, if I'm going to make a rectangle, that fourth point has to be right over here. It's got to be D. D is at negative 3, negative 1. So that's one of my answers right there. That's part of my response right there. And then we're finding the area. The area of a rectangle is just length times width. You can also think base times height, same thing. And so what is this? This would be, from here to here it's 3 and then 2 more. So you've got 5 by 1, 2, 3, 4 right there. So you have 5 times 4. That means the area of this is going to be 20. Or you could say 20 units squared or square units. Those would all be acceptable answers. If they don't give you the units, I don't need to see those, so I'll just put that in parentheses. But if they do give you units like centimeters, inches, etc., make sure you include those in your response, in your answer. From there, number 63 would be our next multiple of 3. Sorry, it's a little fuzzy or light there, but I think you can still read that. We're graphing the equation by plotting points here. And so when it says to do that, our tactic is to make an XY table. So pick a value for X, see what it equals for Y. Really, it is easier to solve this for Y first or to solve it for X first, one of those two things. So since I don't have to get this in slope-intercept form, it's actually going to be a little easier to solve for X. Get that by itself. So why don't I do that here? So I'm going to say that X, this would cancel, equals Y plus 4. So I'm going to pick a value for X, You could have done the same thing with y, though. You could have solved for y and pick a value for x. But I'm going to pick a value for y now instead and see what I get for my x values. So I notice if I plugged in -4, that would give me 0 for x. -4 plus 4 would be 0. So that's 1 point that would exist. If I plugged in, let's just pick a couple more points kind of at random. If I plugged in 2, yeah, let me use 1 instead. I don't want to get too big. I would get the value of x as 5. So 5, 1 would be a point on the graph. If I plugged in, let's say I plugged in -7, -7 plus 4 would be 3 for x. So if I plot these points, I'm going to go 1, 2, 3, 4, 5, and then I went down as a -7, so 1, 2, 3, 4, 5, 6, 7. I'm going to go all the way down to there for right now, and then there's my x-axis. So these are some points. And again, you could have solved for y first. That's usually the way I do it. I just decided to show you a different way here. Either way it works in this case, though. And you'd have a point at 0, -4. You'd have a point at 5, 1. Point at 3, -7. So I clearly did something wrong here because these points do not line up. What did I do wrong? So 0, -4, 3, -7, 5. If I plugged in 5, if I plugged in 1 for y, yeah, I don't know why I did that. -7, that would make this -3. Sorry. So -3, there we go, -3, and then down to -7. Let's count carefully. 1, 2, 3, 4, 5, 6, 7 would be right there. So if I make a straight line, I'm actually going to get out my straight line tool. Notice I used 3 points to do this, because if you just do 2 and you got something wrong like I did there, that's why I did that, right? That's, of course, I'm just trying to show you mistakes that might be made. Right. No, that was just a my bad thing there. I was trying to think too quickly through it. And so you got a straight line. If you just did 2 points, but then you made a third one and it didn't lie on that line, you do what I did. You try to figure out, well, something went wrong, something was awry there, and figure out where you made your mistake. So at least 3 points, plot at least 3 points, and you'll have a good line. Let's check out, oh, I had number 66 here still. So 66, I'm going to do that one in red here. Let's put it on the same graph just to save us a little space here. So x equals 3. Here's x, and if x equals 3, it always equals 3, no matter what y is. So here's a point right here. If I go out to 3, 3, 2 would still be, excuse me, it would still be on the line right there. 3, 0 is on the line. I can go all the way down to 3, -6. It wouldn't matter. The values of x on this line are always equal to 3. So this one's x equals 3, and then the other one was what you saw there. Let's check out number 69 now. We have 4x minus 3y equals 12. It says using the x and y intercepts. So that method, that's when we are saying for the x-intercepts, that's where y equals 0. And for the y-intercepts, that's where x equals 0. And so here I would have, for the x-intercepts, 4 times x minus 3 times 0 equals 12. And then here I would have 4 times 0 minus 3y equals 12. So in both cases, this would drop out here, this would drop out here. This is going to just be 0 and 0. That would mean you would just have 4x equals 12 here. Divide that by 4 and you'll get x equals 3. So here is 1 point. Y is 0, x is 3. The other one, you would have divide by -3 here, and here you'd have y equals -4. So that would cancel out there and there. So another point is x equals 0, y equals -4. So the points on the graph that you're going to have, you can just connect those with a line. So let's draw our graph. 1, 2, 3, 4, 5 will be good. 1, 2, 3, 4, 5. Did I do enough? I'll go one more. I think I missed one. There we go. If I want to go 5 in each direction, that's usually a pretty good way to go, at least with the ones they generally assign in the book. 5 tends to be enough, but just be careful. Make sure you make it big enough. Sometimes it's not. we have 3, 0. That's a point right there. This is my x and y here. So this was the first one, 3, 0. X is 3, y is 0. The other one, x is 0, y is negative 4. So 0 down here to negative 4. There's my line. I'd connect those, the straight line. Notice I'm going up 4 and right 3, so that pattern would continue. I'd go up 4 and right 3. This should be another point on the line, but these are my intercepts right here and right here. If you're graphing using x-intercepts and y-intercepts, make sure you get those points based on what you have here. I will likely be checking that you understand how to do each version, each type, when you are tested on this. So there's our graph, and move on. Let's move on now to the next ones. I've got 72 will be the next one we look at. Find the slope of the line through the given points. The slope, when we're just given 2 points, we should just rely on this. So y2 minus y1 over x2 minus x1. And so all this is coming from this, that the fact that this first one, call that y, x1, y1. Your first x, your first y. Call this one x2, y2. Second x, second y. And then just plug them into the formula. Negative 4 minus negative 1. Careful there. If it's got, the form has a minus sign. If it has a negative with the y values or the x values, the second ones that you pick, you got to plug in a minus and negative. And then here we've got 5 minus 3. This will change to negative 4 plus 1, which would be negative 3. And this would be 5 minus 3, which is 2. So you have negative 3 halves for your final answer there. Forgot to put my little 72 there. So moving on now to 75, and we'll also be doing 78 here. Graph the equation by plotting the y-intercept and by plotting the second point, by making use of slope. That's all a fancy way to say use slope-intercept form. So slope-intercept form, we find the slope-intercept form of the equation first, then we plot the y-intercept after that, and then we use the slope to make another point. So use slope-intercept form for both of these. We are going to be plotting, so I'll put the grid up here in just a moment. Boom, like magic, there it is. All right, 75. We've got y equals 2x minus 5. This one's all good to go. This is like saying y equals 2 over 1x plus 5 to put it into a slope form that's more directly applicable or easily understandable on the graph. So this one, let's draw 5, 1, 2, 3, 4, 5. Okay, we'll go 5 in each direction again. We'll be hitting the y-intercept right at negative 5, right towards the bottom of that with this. So this one, I'll do this one in black, sorry, that's right there at negative 5. And then you're going up 1, or up 2, right 1. That's the slope of 2 over 1 here. So up 2, right 1, up 2, right 1. That pattern is going to continue. You keep getting more and more points. I'll plot a bunch of them and then connect them with a straight line. So this is y equals, this is number 75 right there, y equals 2x minus 5. This other one, I'll do this in blue just to make it easily distinguishable. We've got y, this is already in slope-intercept form. These two weren't, 76, 77, not in slope-intercept form, so you should know how to do that first though by solving for y. Get y by itself, and then you got it in slope-intercept form, and then do your thing from there. But 78, that's the one we'll focus on here. We've got y equals negative x minus 1. You can think of that as negative 1 over 1x minus 1 to put that into a slope-intercept form that is directly applicable to the graph, or directly relatable, easily applied to the graph. So negative 1 is right there for the y-intercept, and your slope is negative 1 over 1. That means each time I go down 1, I would go to the right 1. That would be like negative 1, the rise part, over positive 1, the run part, negative 1 over 1. That pattern would continue, so I could make a bunch more points if I want to. If I went up 1, that would be the same thing as 1 over negative 1. I could think of that, those two things meaning the same thing. So up 1, left 1, up 1, left 1. That pattern would continue going that way. So I connect all those, and voila, I have my answer for number 78. This is y equals negative x minus 1. That's the graph of that line right there. Moving on now to number 79. I wanted to do one of these together with you. I know it's not a multiple of 3, but it's one that did get assigned. It got included into there. And so here, let's figure out, determine the equation of the graph. Slope-intercept form, I think, is the easiest way to do that. There's your y-intercept right there at 4. And so for 79, I'm just going to leave this part blank for now, the slope part. But I have whatever x plus 4. And notice from one point to another point, I'm going up 4. This is a rise of positive 4. And I'm going to the right 2. That's a positive 2 if I go up and to the right. And remember, we probably talked about Super Mario Brothers and Super Mario 1. He's running uphill. He is having a positive slope then. There's a positive slope to this line if he's running uphill as you move left to right on your TV screen. And so we have 4 over 2. That can be reduced down to just plain old 2. So 2x plus 4. That should be my final answer for number 79. Number 80, you can try that one. Just like with the other ones we're not doing here, you should know how to do them. 81. We've got disability income here. The monthly disability income, L, that Naja Muhyiddin receives is I guess that's an I. Yeah, I think that's a capital I. I equals 460 minus 0.5 M, where M is her monthly earnings for her part-time job for the previous month. So let's draw a graph of disability income versus earnings for earnings up to and including $920. So I think a good idea, well, of course to have a grid here, to have graph paper makes it a lot easier, but to also make an XY table or use slope-intercept form, either way, to help us graph this. So with the graph for part A, I know I'm not going to have to go and talk about negative income here at all. This is going to be your earnings. We're not going to be making negative money in a month. So I'm just going to include the positive part of this graph here. And we're at 460. This is what I'm most focused on. So 460, I'm going to go up by, looks like 100 would be a good idea here. So 100, let's say each one is 100. But so I don't cram it all in there, I'll just go up 200 like that at a time. But each one of these is being 100 for us. And I'm going to do the same thing going this way. 100. This one's going to need to be a little bit longer, but it looks like I have done that already, so I think we should be all set there. There's 300, there's 400, 500, 600, 700, 800. This would be 900, and 1,000 right out here. But if I think of this in terms of slope-intercept form, I'll do that over here. This is slope-intercept form would look like I equals, this is like your y. The I becomes, or is the y. You have negative 0.5. That's the same thing as negative 1/2. Excuse me. Times the monthly earnings plus 460. So this is the y-intercept right here. This is the slope right here. You could also use plotting points, the XY tables, to do this. But 460, that's going to be in between 400 and 500, but just a little bit higher than halfway. Man, talking too much. I wonder why that is, man. All right, so then going down 1, which we could say is the same as going down 100 every time we go to the right 200. So we'd have another point here, another point here, 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 and if we went down one more time, we'd have another point right about there. So this is going to cross. Well, if I had, what would my x-intercept be over here, or my m-intercept in this case, because this is representing income, this is representing monthly earnings. What would that be right there? Well, if we plugged in says up to and including 920, so I don't want to go there. So 920, if we plugged in 920 half of 920 is 460. 460 minus 460 would be 0. So at 920, that's where this should intersect. So this point right here, just for your information, that's 920 and 0. And then this point right here is at 0, 460 for terms of monthly income versus disability income received. So we have this right here is going to be, since it's an equation, it's a solid line, that's representing the earnings for Nadja. Alright, part B. Nadja earned $600 in January. How much disability income will she receive? We can use the graph to kind of verify what we have here, but we should just plug in 600 right there into the equation. So I equals 460 minus 0.5 times 600. That's half of 600. I'm sorry, I'm plugging it in the wrong spot. I'm like, that's going to give me a negative number. This we want to leave as the variable. How much monthly income, the disability income, is M. This I want to say is 600. So we're solving for M instead. So 600, that gets plugged in right here. Solving for M, if I would subtract 460, first of all, that would give me 140 equals negative 0.5 M. Divide by negative 0.5, and that'll make, yeah, it's just one of those problems. Hold on a second. I was doing it right at the beginning. Silly, 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 silly. Got to read it more carefully. So this, she is making 600. She earned $600. M is the monthly earnings. Okay, so that gets plugged in there. It's not going to be negative though, because this will be half of 600, which would be 300. So minus that, this is her disability income I. That is what I'm solving for here. Got to slow down sometimes. So the I is going to equal $160. So part B, we should have $160. And then part C, if we could look at the graph too, we can verify that at 600. That looks like it's about 160. So that's a good way to check your answer there. And now, if she received $380 disability income in November, we're talking about the previous month. How much did she earn in October? This is the one where now I want to plug this in. Here it looks like. So I'm plugging in the disability income as 380 and solving for the monthly income she earned in the previous month now here. So at 460 minus 0.5 times M. If I subtract 460, this looks a little more reasonable here, and I'm going to have negatives to start with, but dividing by the negatives will get rid of that. So this would be negative 0.5, divide by negative 0.5, and they happen to make it so it was the same number here. So M is going to equal, if I divide this in by 1/2 by negative, that'll make a positive 160 again for M. Moving on now to number, nope, I didn't insert any extra ones in here, so number 84 is our next one. Graph the inequality. 84, you've got 3x plus 2y greater than or equal to 12. So it looks like we should be getting a grid here, so I'll put that up just a second. So there we go, and then slope-intercept form, definitely the best way to do these kinds of problems, I think. Pretty much any graphing problem, I think, slope-intercept form, in my opinion at least, it's the easiest way to graph things almost without fail. So divide everything by 2 here, you'll have y greater than or equal to negative 3/2 x plus 6. So we want to graph this. It looks like I need to go to positive 6, so I'm going to go a little bit higher than I normally might here. And then graph like that. I'm going at positive 6 as my y-intercept. 1, 2, 3, 4, 5, 6. And then I'm going down 3 every time I go to the right 2. Negative 3/2 as my slope. So down 3, right 2, down 3, right 2, pattern continues. It is or equal to, so this is going to be solid rather than dashed. If it was not or equal to, that's just a dashed line instead. And so this point, you notice this is at 6, 0, or 0, 6. This is at 4, 0 right here. And then it is stuff that's greater than or equal to. So think of that kind of as a roof. We are shading above the roof since it's greater than or equal to in slope-intercept form. You have to have it in slope-intercept form for it to work like that. But there is our answer for 84. Number 87 now, and number 90, we'll also be doing that one. Factor the trinomial. So a little bit of factoring. Shouldn't need any grids here. If the trinomial cannot be factored, we need to state that case, or state that it can't be. So if this helps you, great. If not, if you can just think of what the factors are without making something like this magic X type thing. Not really that magical, but it's got some magical properties to it. Yeah, right. So what multiplies to 18 and adds to 9? Which two factors, which two numbers would do that? Well, that would be, what do we got here? We'd have a 6 and a 3 would definitely do that. So 6 and 3, you could say 3 and 6. The order wouldn't make a difference. 6 and 3, or x plus 3 times x plus 6. Both would be totally fine. And then for x squared minus 9x plus 20, I guess I didn't write that originally up here. It was okay, didn't have to, but we had that to start there. Now we have this to start. What multiplies to positive 20 but adds to negative 9? So are there factors that will do that for us? Well, it looks like if I had two negatives, that's the only way that's going to happen. They both would have to be negative for me to get something that multiplies to positive but adds to get a negative. So we have minus and minus can definitely get filled in there, and then 4 and 5 would be the ones that would multiply to 20 and add to 9 there. So we'd have the order again wouldn't matter. X minus 4, x minus 5, you could flip-flop those two binomials, but you have to have those two multiplied together. Number 93 now. Solve the equation by factoring. And 96 being a multiple of 3 here. So x squared plus 3x plus 2. If you want to do the magic x to help, you can, but on this one I'm just going to say, hey, this is what it is, because I know I'd have to have x times x for x squared. I know I'd have to have 2 times 1. That's the only way to get 2. And so hopefully this works out. 2x, 3, and 1x for 3x total for my outside and inside pieces of foil. That worked out. So the thing that's going to make this true, this part, this number would have to be negative 2 to make this part equal to 0, which would make the whole thing equal to 0. And this part would have to be negative 1 to make this part equal to 0, which would also make the whole thing equal to 0. So your solutions here should be negative 2 and negative 1. And if that wasn't making sense, remember you can say x plus 2 equals 0, solve for it like that. And you can do the same thing over here. Set each factor equal to 0 and solve for it like that. Number 96, got 3x squared equals negative 7x minus 2. From there, add 7x to both sides. We need to get one side equal to 0 and add 2. So we need to have that first to start. So we have 3x squared. The x part comes next. The regular number comes after that. That equals 0. And then factor it. It says solving it by factoring. So 3x times x. That's the only way to get a 3x squared part to start. And you're going to have 2 somewhere and 1 somewhere. That's the only way to multiply to get 2. Those are only 2 factors of 2. So if I put a 2 here and a 1 here, let's see what happens. This would be 2x and this would be 3x. So my outside and inside pieces would add to 5x. That's no good. So a little trial and error here. That didn't work. But if I flip-flop those, it should work. So I'm going to have now a 1 here instead of a 2 here. This would be 1x. This would be 6x. That does add together to get 7x. So from there, you can set each one equal to 0 and solve that way. Or if you just look at it, this one, if that was 1/3, I would have 1 plus 1. So if it was negative 1/3, I'd have negative 1 plus 1, which would make that 0. This one right here, negative 2. You can do the same thing here though again. You can say 3x plus 1 equals 0 and solve it for x. You can say x plus 2 equals 0 and solve it for x. Both those ways work. Alright, moving on to number 99. solve the equation using the quadratic formula. So quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. We're using that for number 99. So 2x squared minus 3x plus 4 equals 0. What's your a, b, and c? Your a is 2. Your b is negative 3. Your c is negative 4. So we're just taking formula, plugging those numbers in. So we have x equals negative, the opposite of negative 3, plus or minus b squared, which is negative 3 squared, minus 4 times a times c, all over 2 times a. So just simplify this now. We get 3 plus or minus, that would be 9. This would be 32 over 4. So we'd have 3 plus or minus, and you'd get a negative number, a negative value under the square root here. When that happens, we say there's no, at least, real solution. So negatives under the radical. This is the discriminant part. It kind of discriminates between solutions and no solutions. So negative under the radical implies there's no solutions to this. If there were solutions, though, remember, you should take this. You have two options, that number plus or minus whatever this is over whatever that is. You've got those two things as possibilities. Onward to 102 here. Multiple of 3 there. Determine whether the graph represents a function. If it does, give its domain and range. So this one, because it does not pass the vertical line test, here's a vertical line, not a perfectly drawn vertical line, but doesn't pass the vertical line test. So for 102 you would say no. If it does, though, domain, remember, is all possible x values. So like here it would be everything, y values it would be everything, but here the domain would just be the x values you see here, 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 and here. The range would just be the y values you see here, 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 and here. This one doesn't pass the vertical line test either, so that one wouldn't work. But 102, check out those ones in the back for extra help. If you want to try those, you should know how to do all 4 of these. Just as with the rest of these, you should know how to do all of them that show up here. Okay, for this, ooh, that looks pretty straightforward here. It's not 10.5, it's 105 though. So we have f of x equals 5x minus 2 when x equals 4. So we just need to plug in 4. We get 20 minus 2, which is 18. And for 108, we're plugging in 4 for x into the function. We get negative 4 times 4 squared plus 7 times 4 plus 9. This is negative 4 times 16 plus 28 plus 9. That is negative 64 plus 28 plus 9. Negative 64 plus 28, what would that be? That would be negative 36 plus 9, which is negative 27. Okay, moving on to 109 now. 109, we've got the parabola opening upward or downward. This is going to be a pretty involved question here. We're going to have a lot to figure out here. So 109, part A, determine if it opens up or down. That all depends on this right here. If this is negative, it opens down. If it's positive, it opens up. This is negative, the a value, the value in front of the x squared, so it opens down. And our reason would be a is less than 0. Part B, the equation of the axis of symmetry, that was x equals negative b over 2a. So we plug in, what are my a, b, and c values? My a, this is like negative 1. My b value is right here, negative 4. C value is right there, 21. So I'm just plugging in negative 4 over 2 times negative 1. That would become positive 8 over negative 2. So x equals negative 4 is my axis of symmetry. I'm good at math, I promise, right? This is not that though. Most of the time. This is 4, not 8, so this would be negative 2. Sorry, there we go. So now that's good. C, find the vertex. So this is my x value with the vertex. If you want a more thorough explanation, go back to the notes. If you're one of my students, go back to the notes we took on this section. But we have x equals -2. That's the x value of the vertex. And so we're going to find the y value by plugging that in. So y would equal negative, and then we have -2 squared minus 4 times -2 plus 21. I'm just going back to this original equation right here and plugging in -2. So I have negative, and then this would be 4. That negative sign is still out there. This would be plus 8 plus 21. All that put together is going to be, this would be -4 plus 8 is positive 4. 4 plus 21 is 25. So we'd have a vertex at -2, positive 25 right there. Part D, you find the y-intercept. That's where x equals 0. So if we plug in 0 for x, we'd have 0 squared, we'd have times 0 plus 21. This would cancel, this would cancel. That one's pretty straightforward. You have y equals 21, so that means the y-intercept is at the x value is 0, the y value is 21. For the y-intercepts, for the x-intercepts, I'm sorry, we have to say that y equals 0. So this is where we have to use the quadratic formula stuff or factoring, whichever way works easier. Factoring doesn't work, then we have to use the quadratic formula. So we have -x squared minus 4x plus 21. A little trick you can do, though, is divide everything by a -1. 0 divided by -1 will still be 0, and that'll just make these things easier to deal with. Positive for x squared, positive here, that one will change to negative. If you can factor it, might as well, and this one you can. So we don't have to use the quadratic formula. We can say x plus 7, x minus 3. That combination would give me 7x and -3x, which would add together to get -4x. So the x-intercepts would be at -7 right here and at 3 right here. So we have x-intercepts are at, we can say the y value is 0, remember, so -7, 0, and 3, 0. Those are the x-intercepts. Now I'll sketch the graph, find the domain and range. Now it looks like I'm going to go to a new page for that. So let's continue this here on another page, part F. We're sketching the graph, and it's going pretty high here, -2, 25, and so let's go by 5s. It looks like that'll be a pretty good idea. Or you know what, let's go by 2s. I'm going to make this huge, because I can, because I want to. Okay, so huge graph here. I'll go by 2s. So this is 2, 4, 6, 8, 10 right here, 2, 4, 6, 8, 20, 2, 4, and so on. 1, 2, 3, that'd be 4, that'd be 8, and -10. 12, 14, 16, 18, -20 right here. And so on, 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, and 2, 4, 6, 8, that'd be -10 down here. This is 0. Okay, so I've got, start with the vertex. Got a vertex at -2, positive 25. So -2, positive 25 would be right there. This is 24, this is 26, so halfway in between there. That's my axis of symmetry right here. I'll put that in red. Not necessary to draw that, but that's where it would be, axis of symmetry. And then from there, my y-intercept was at 21, I believe it was. Is that right? Yep, 21. And then x-intercept's -7, 0, 3, 0. At 21, we've got a point. We've got a point at -7, 0 right there, and at 3, 0 right here. And so this one would be symmetric here and here. We'd have another point right there. If I connect these, there's my parabola. There it is. And so that continues on forever in that direction and in this direction. And so that's the graph of that. And then G, the domain and range. Domain is all possible x values, which would be all real numbers. Everything would work there. You can plug in anything for x. but the y values can't get any higher than that right there. They're not going to get any higher than 25, which was that point right there. So the range would be all y values such that y is less than or equal to 25. So not as bad as I thought. I thought it might take more time, but we didn't have to use quadratic formula, so that made it a little quicker for us there. But you should know how to do 110 as well. And now, let's see, did I skip one that I didn't want to skip there? No, I think we got them all. 111, 113, 115, and then we'll be there. So 111, 112, draw the graph of the function, state the domain, and range. So we're starting with y equals 2 to the 2x power. With these exponential types, I think this is the best way to go about it. Let's do at least 5 points here. We might do a couple more. I'll get out. I'll make the grid again. There we are. If I plug in -2, I'd have 2 times -2 here. That would be 2 to the -4 power, which would be 1 over 2 to the positive 4, which would be 1 over 2 to the positive 4 is 16. So 1 over 16 right there. Similarly, I'd have 2 to the 2 times -1, which would be 2 to the -2 power, which would be 1 over 2 squared, which would be 1 over 4, not 14, 1 over 4. I was going to say 14. 2 to the 0 power is just 1. Anything to the 0 power is 1, except for 0 to the 0. That's just weird. And then this would be 2. 2 squared would be 4. So we just need to graph this and this. That pattern would continue. That would hold like that. So let's draw a graph. And we're going, looks like we can just keep mostly positive there like that. And we're going -2. I'd have a point really, really close. And then pretty darn close still right there. This would be at 1. And then 2, I'm going, at 1 I'm going up to 2. And then at 2 I'm going up to 4. If I did another point, if I did 3, I'll just do that for fun, because I can. And what was I doing here? I am not getting this right. I'm trying to go too fast. I'm getting rushed here towards the end. So this one, this was supposed to be 2 to the 2x. So this would be this times 2 still, which would still be 2 to the 0. But this one should be 2 to the 1 times 2, which would be 2 squared. This one should have been 4. I'm sorry about that. And then this one should have been 8 instead, because this would be 2 times 2 here, which would be 2 to the 4th, which would equal 8 there. So this last one, or this other one, we'd have 2 to the 2 times 3, which would be 2 to the 8th, which is going to get huge really quickly. So 2 to the 8th power, 2 to the 8th power is 256. So you'd have 256. That's going to be off our graph. It's going to be way, way out there. So notice this one will get quick, or will get higher, will be increasing very, very quickly after we get to this point. So we have like that, and we have 2, and we have 1, 2, 3, 4, 5, 6, 7, 8. Just fits. No way this is going to fit on here. So 3, it's going to be way up there. That's going to grow very, very fast. I can hardly draw the graph right. It's still a curve, but it's almost starting to look like a straight line at this point when I get up there. So from there, we got just a couple more here. Domain and range though. Domain and range. The domain would be, you can plug in anything for x and it works. So domain is all real numbers. The range, you can't get to 0 and you can't get any lower than 0. So you're going to have the range, it's all y values such that y is greater than 0. Not greater than or equal to, but just strictly greater than. Let's look at 113. Let's look at some gas mileage here. 113. We've got this equation, m equals 30 minus this, and we're saying for values here, estimate the gas mileage 60. So 60, it falls in this range. That's okay. That checks out. So we have the mileage is going to equal 30 minus this, 002 to the 60 squared power. So we'll type that into a calculator. Let's get my calculator out here. I'm going to wait to subtract that from 30. So I'll have 60 squared first. That's going to be 3,600. That times 0.002 would be this. So I'm subtracting 7.2 from 30. So I have 30 minus 7.2. Therefore, my answer should be 22.8. This is at gas mileage, so this is miles per gallon, mpg. And 115, that's on the next page. Sorry, that's the last one here. 115, the percent of light filtering through Swan Lake P can be approximated by the function. So here's our function. P of x is 100 times 0.92. The x power, x is the depth in feet. Find the percent of light filtering through at a depth of 4.5 feet. So this is just a matter of taking that, plugging that in for x using a calculator to get what that answer is. So 0.92 to the 4.5 power. Calculator again. Here I'm going to take let's clear that out, 0.92 to the 4.5 power equals that, and that times 100, not 1,000. If I divide that by 10, that'll give me what I should have. There we go. That's going to be my final answer there. About 68.71%. 68.71%. Final answer for 115. Made it. I'm trying to do this on my lunch break, and I just made it. So finished up. There we are. Those other ones though that we did not do, you should know how to do those. Ones like those might show up on the test that you're taking if you're one of my students. And hope you have a wonderful day, everybody. Hopefully you found that helpful, and hopefully you'll be ready for that test coming up very soon.